In this video, I'll be discussing about theorems on central angles, arcs, and chords. For theorem number 1, it states that in a circle or congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Suppose we have a circle whose center is at point E. Therefore, this circle is named as circle E. And we draw another one whose center is at point I. So this circle is named as circle I. From circle E, we choose a point and we name this as point S together with another point on the circle, and this is point P. Now drawing a radius or a segment from point E to each of these selected points, we have a central angle whose name is angle SET. And suppose this angle has a measure of 50 degrees. Therefore, the measure of its intersected arc ST is also 50 degrees. Now, what if we draw another central angle? So we choose another 2 points on the same circle. Say this is point O together with the fourth selected point, which is point N. And just like what we did on the first central angle, we draw another one. So we form two radii from point E to each of these points, O and N. And we have another central angle, which is named as angle OEN. And suppose the measure of this angle is also 50 degrees. Therefore, its intercepted arc, ON, is also 50 degrees. So, in circle E, central angle SET is congruent to central angle NEO or OEN. Now, since these two central angles are congruent, the minor arcs they intercept, meaning arc ST and arc ON, are also equal in measure or congruent. Therefore, or thus, arc ST is congruent to arc NO. Now, suppose we consider the second circle and we choose a point, say point G, together with chosen point B. So in circle I, we form a central angle whose name is central angle BIG. If we are going to draw two radii from point I, going to point G, and from I going to point B. Yan. And let's just say that the measure of this central angle is 50 degrees. It means that its intercepted arc BG is also 50 degrees. Therefore, if circle E is congruent to circle I, and the three central angles are congruent to one another, therefore, or then, their intercepted arcs ST, NO, and the arc BG are all congruent, meaning each of these three arcs measures 50 degrees also. So that is your first theorem. Now we go to the second one, theorem number 2. Theorem number 2 states that in a circle or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Now again, we draw circle whose center is at point T. So this is circle T. So in this circle, named circle T, so we choose a point, point B, and another point from the same circle, which is point A, and we connect these 2 points by a segment, so we have segment BA. As we all know, this segment is what is known as the chord. Now, suppose this segment is congruent to probably another chord whose name is chord or segment CH, okay, whose endpoints are also points on the circle. And these are point C and point H. So connecting those points by a segment, we have a chord whose name is segment CH. So we assume that these two chords are congruent. So segment BA is congruent to segment CH. So what does this imply? Now, based on the statement, if the two chords on the same circle are congruent, then their corresponding arcs are also congruent, meaning segment BA or arc BA is congruent to arc CH. So yun ang ibig sabihin ng theorem number 2. Again, we read the statement: in a circle or incongruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. But here, we only consider so far congruent arcs on the same circle. What if the arcs are on the different circles? So in this case, we draw another circle whose center is at point N. And so this circle is named as circle N. And in this circle, we choose 2 points. So therefore, if circle T is congruent to circle N, so again from circle N, we choose 2 points to form a chord. So if these two circles are congruent and segment BA is congruent to segment CH, which is also congruent to another chord drawn from circle N. Say that chord is segment OE. So we choose 2 points on circle N, and these are point O and point E, connecting them by a segment. So we have a chord whose name is segment OE. Now, together with the other 2 chords, they are equal in length or congruent. So what does this imply? It means arc BA, which corresponds to segment BA, is congruent to arc CH, which corresponds to chord CH, is also congruent to the third chord of circle N. So yun yung ibig sabihin ng statement. Again, we read the statement: in a circle or in a congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So ibig sabihin, if segment BA is congruent to segment OE, therefore, arc BA is congruent to arc OE. Or pwede rin, if segment CH of circle T is congruent to segment OE of circle N, therefore, their corresponding arcs are also congruent. So, that is arc CH is congruent to arc OE. Okay, so that is statement number 2. Of course, the two chords and on the same circle are equal, so it follows that their corresponding arcs are also equal or congruent. Next, we go to the third statement or third theorem, and it states that in a circle, a diameter bisects a chord and an arc with the same endpoints, if and only if it is perpendicular to the chord. Okay, let me explain also the third theorem. Now, suppose you have a circle whose center is at point U. The name of this circle is circle U. And from this geometric figure, we draw a segment passing through the center. So we consider points along the circle, and that is point E together with point S. If we're going to connect these 2 points on the circle, you will notice that the segment that connects point E and point S also passes through the center, which is point Q. Therefore, that segment is what we call the diameter. So, segment ES from circle U is a diameter. And along with that circle, we draw another segment connecting point G and point N. So that is segment GN, which is known as the chord. Okay. And it's just so happened that the diameter and the chord intersect one another. Now suppose segment ES, which is our diameter, is perpendicular to segment GN, meaning these two segments intersect each other at a right angled vertex, as indicated by a small square drawn at the corner, and their intersection is at point I. So if this is the case, if the diameter is perpendicular to the chord, then the chord is actually divided into two equal parts. So segment GI is congruent to segment IN. Okay? So that is what we mean by theorem number 3. Okay? The diameter bisects a chord if this diameter uh, form a right angle with the chord, or if the diameter is perpendicular to the chord. Okay? And also, not just the chord is bisected, but also its corresponding arc, because the chord and this arc share common pair of endpoints. Ayan. Okay, so chord arc GE is congruent to arc EN. Okay. Now suppose we draw a segment from the center to point N, as indicated by this broken line segment. Now in a circle, this segment is actually our radius. Okay, UN. And because of this segment drawn from, from this circle, we just formed another geometric plane figure, and that is obviously a right triangle. So again, UN is our radius, and because of that drawn radius, we form a triangle, and not just triangle, but a right triangle, whose name is triangle IUN. And because of this right triangle, we also consider the relationship among the sides of this triangle. And we know that in a right triangle, the two sides that form a right angle are the legs, and the longest side is known as the hypotenuse. And in a triangle, there is a formula that illustrates the relationship among the three sides of the right triangle. And that is the Pythagorean theorem, which states that in mathematically, particularly in this triangle, segment ui squared plus segment in squared equals segment un squared. Okay, so if we're going to verbally interpret this formula, it states that the sum of the length of the legs in a right triangle is equal to the square of the hypotenuse. Okay, now what if from this circular figure, the length of the radius is given as 5 and segment ui, which is this one, has a length of 3. Now, what would be the length of the following segments? Segment GI, segment IN, segment GN, and segment IE. Now, among the 4 unknown segments, we can look first for the length of segment IU using this formula. So we directly substitute the given 2 segments from this formula in order to compute for, IU is already given. What we're going to look for here actually is the length of segment IN. Okay? IU is given, UN is given. Okay? So we rewrite the formula and then substitute the given segments, the given lengths of those segments. So from UI, that is 3, so that is 3 squared plus IN squared, the one we're going to look for, equals UN, which is actually the radius, whose length is 5, so that is 5 squared. And then solving for n from this equation, we transpose the result of 3 squared to the right side and subtract it from the square of 5. So that will be your IN squared, which is now equal to 25 minus 9. And 25 minus 9 is 16. And to get IN, we get the square root of both sides. So that the left side will simply IN, but on the right side equal to the square root of 16. And we know that square root of 16 is 4. Okay, so we're done solving IN. So what are the segments remaining to be solved? So that is segment GI, segment GN, and segment IE. So the next segment to look for its length is segment GI together with segment GN. Now, going back to the theorem, mathematically speaking, since the diameter intersects perpendicularly with the chord, it means the diameter divides the chord into 2 equal parts. So, since segment GI is equal to segment IN, which are part of the segment, the chord, segment GN, which is a chord, and we have just obtained the length of segment IN, which is 4, it follows that GI, or segment GI, is also equal to 4. And with that, we can now easily determine the length of segment GN, which is the chord. And the length of the chord, segment GN, is 8. Okay, now that brings us to the last segment, IE. So what is the length of this segment? Now you will notice that from center U going to circle E, this segment right here can be considered also as a radius. And we know that the radius is 5. And we have just determined, or we know that from the given information, the length of segment IU is 3. Now, if we subtract 5 from the length of segment IU, which is 3, what will remain is the length of segment EI. Okay, so it's a radius. So AI is actually the difference between segment UE and segment IU. So substitute their given values. UE is 5 minus ui, which is 3. So your segment IE has a length of 2. So these are your answers.